Newton's first law says that an object at rest remains at rest, or if its motion remains in motion at a constant velocity, unless acted on by a net external force. A force is a push or pull exerted on one object by another object. Therefore, the units of force F are called newtons or simply N. An external force is a force originating from outside an object rather than a force internal to an object. For instance, the force of gravity that Earth exerts on the moon is an external force on the moon. The net force on an object is the total force on an object. If many forces act on that object, then the net force is the sum of all the forces. Newton's first law says that if the net force of an object is zero, then that object will have zero acceleration. That doesn't necessarily mean the object is at rest, but it means that the velocity is constant.
Okay, so what I'm trying to prove here is that the bottle cap stays in the same place since the force applied to the piece of paper isn't greater than the frictional force, so it should not move. It does not move because, as I said, the force applied to the piece of paper isn't greater than the force applied to the frictional force. Now, if I do this, like put the piece of paper here, and then if I do this, that happens because the bottle cap stayed in one place because the frictional force applied to the piece of paper was great enough to counteract the frictional force, and once the paper was pulled out, the gravity pulled the bottle cap to the bottom of the glass.